Hello everyone, I Govinda Gahine, lecturer in mining department at Chhattisgarh Swami Vivekanand Technical University, Bhilai. Today I will discuss on lecture number 2, exploratory drilling. So, what is exploration? The process of collection of rock sample data for assessment of rock properties at a site through series of laboratories and field investigation is collectively called exploration. Enables the engineers to draw rock profile indicating the sequence of strata and the property of rock involved. The main objective of the exploration is to find out the nature of deposit, depth, thickness of strata, horizontal extent of deposit, depth of GWT and its fluctuation, engineering property of rocks, in situ rock properties, collection of rock samples. The method of exploration is divided into three parts. First is direct method, second semi-direct method, third indirect method. So, in direct methods, test pitting, trial pits, trenches. For semi-direct, boring, auger boring, wash boring, percussive drilling, rotary drilling and Odex. Third one is indirect method. In indirect methods, surrounding or penetration test and geophysical methods. In the direct method of test pitting is depth up to 3 meters, uneconomically at greater depth, supports are required at greater depth, especially in case of weak strata. Problem with GWT and the same should be lowered. Open type exploration, soil are investigated in natural condition, soil sample are collected for determining strength and engineering properties. You can see on this figure the excavated test pits. It's look like a square shape. In the second method, semi-direct method means drilling and boring, in which drilling is a hole into the soil or rock strata up to specified depth is known as boring. The exploratory drilling method are classified are as follow. First one is auger drilling, second one is wash boring, third percussive drilling or churn drilling are also called cable tools. Fourth one rotary drillings and last one fifth is Odex. So, first auger drilling. Drilling is made using a device called soil auger, power driven up to 3 to 5 meters and hand operated greater than 5 meters. Advancement is made by drilling the auger by simultaneously rotating and pressing it into the soils. Dry and unsupported boreholes, when the auger gets filled with soil, same. It is taken out and the soil sample collected. You can see on the figure. Casing is provided in case of weak strata. First the casing is driven and then the auger. Boring ring is used for power driving, hand ring for depth up to 25 meter. Soft rock are broken using chisel bits. Sand pumps are used in the case of sandy soils. The disadvantage of auger drilling is whenever the casing is to be extended, the auger has to be withdrawal, which hinders the quick progress of the work. Then wash boring. Below GWT, it may not be used for soil mixed with gravel and boulders. Inertially, the hole is advanced for a short depth by using an auger, then a casing pipe is pushed in and driven with a drop weight. The driving may be with the aid of power. A hollow drill bit is screwed to a hollow drill rod connected to a rope, passes over a pulley and supported by a tripod. Water jet under pressure is forced through the rod the bit into the holes. This loosens the soil at the lower end and forces the soil water suspension upward along the annual space between the inner wall of the drill holes and outer wall of the hollow drill rods. You can see on the figure, this is a typical surface arrangement of wash boring. You can see that tripod to support the drill drill arrangement and water nose to flushing and pulley for support to rope and drill rod and drill bits and winches and sump to collect water and casing to prevent the drill hole and for free smoothing rotating of drill rods and drill bits and rods. Then percussive drilling, also called churn drilling. A heavy drill bit called churn bit is suspended from a cable and is driven by repeated blows. Water is added to facilitate the breaking of stiff soil or rocks. The slurry of the pulverized material is built out of at interval. The disadvantage of percussive drilling are cannot be used in loose sand and it is slow in plastic clay. The formation get badly disturbed by impact. In case of hard soil, soil rock, auger boring or wash boring cannot be employed for such strata. Percussive drilling or cable tools drillings method is usually adopted. Here advancement of hole is done by alternately lifting and dropping a heavy drilling bits which is attached to the lower end of the cable. At interval, the bit is removed from the holes and cuttings are withdrawn with the help of baler. You can say on the figure, this is percussive drilling bits, tricone type of drilling bits. Next is rotary drilling. Suitable for rock formation, a drill bit fixed to the lower end of a drill rod is rotated by power while being kept in firm contact with the hole. Drilling fluids or bentoite slurry is used under pressure which brings up to the cutting to the surface. Even rock cores may be obtained by using suitable diamond drill bits. The disadvantage of rotary drilling is not used in porous deposit as the consumption of drilling fluids would be high. Rotary drilling method of boring is useful in case of highly resistant strata. It is related to finding out the rocks strata and also to access the quality of rock from cracks, fissures and joints. Here the boreholes are advanced in depth by rotary percussive method which is similar to wash boring techniques. A heavy strings of the drill rod is used for choking action. The broken rock of soil fragmented are removed by circulating water of drilling mud pumped through the drill rods and bit up through the bore hole, from which it is collected. It is setting tanks for recirculation. If the depth is small and the soil stable, water along can be used. However, drilling fluids are used as they serve to stabilize the borehole. Drilling mud is slurry or bentoite in water. The drilling fluid causes stabilizing effect to the boreholes, partly due to higher specific gravity as compared with water and partly due to formation of mud, cake or on the side of the holes. As the stabilizing effect is imparted by these drilling fluids, no casing is required if drilling fluid is used. You can see on the figure, this is rotary drilling bits, tricone types of bits basically used for rotary drilling in the case of exploratory drilling. Odex drilling. 90% of the land surface of the earth is covered with loose unconsolidated material such as soil, clay, silt, sand, gravel and boulders, which vary in depth from a few centimeter to 100 meters. Drilling through this so called overburden is often problematic due to the tendency of the earth to cave in being the drill bits. This makes it difficult to retrieve the drill strings after the hole has been drilled. In practice, the borehole has been lost before a casing tube can be inserted to support it. Other problems are caused by cavities or porous ground which interface with the circulation of the flushing medium and prevent the drill cuttings from being flushed out of the hole. In places where overburden strata are mixed or when their drillability is unknown, it is difficult for driller to decide what tool to use in order to get the best overall result without risking the loss of equipment in the hole. Odex equipment enable you to drill and case deep hole simultaneously in all types of formation, even those in large boulders. The word is short for overburden drilling. Eccentric, the drilling is used casing to line the holes when passing through the soil overburden before entering into the sound rock. Casing diameters from 89 mm Odex 76 to 273 mm Odex 240 can be used. The method is based on a pilot bit and eccentric reamer, which together drill a hole slightly larger than the external diameter of the casing tube. This enables a casing tube to follow the drill bits down the holes. The most frequently used diameter of hole is 127 mm, with casing having an inner diameter 115 mm. Next is core barrel. To collect the core of rock drill, a device is known as core barrel. Core barrel retains rock sample for drilling operation. The length vary from 0.5 to 3 meters generally. There are three types of core barrel used in exploration purpose. First is single tube core barrel, second is double tube core barrel and third is triple tube core barrel. So, first single tube core barrel. Most rugged and least expensive, it consists of hard section, core recovery tube, reamer, shell and cutting bits, often used as starter when beginning core operation. Coring in homogeneous hard rock where the core does not wash away or crumble easily and penetrating rock layer of the strata where high core recovery is not essential. Single tube barrel are often used as starter barrel during the beginning of core operation. A single tube core barrel is suitable for homogeneous formation where the core is not eroded by flushing water and a soil can be taken without risk of blockage in the barrel. In the single tube core barrel, the limitations are wrong interpretation of stratification, probability of loss of information during core recovery. You can see the figure of single tube core barrel. The structure of single tube core barrel is similar as on the figure. Next is double tube core barrel. Double tube core barrel is used for standard practice. Outer barrel rotates with cutting beds. Inner barrel is either fixed or survival types without bearing that retains core samples. Core diameters generally range from 21 to 85 mm. The standard diameter of annex core size is 54 mm. Double tube core barrel are survival head, i.e. the inner tube is attached with the core barrel hand through bearing, which makes the rotates of the inner tubes independent of the core barrel. It offers higher percentage of core recovery and little erosion of cores. Water in the double tube core barrel passes in the between the outer tube and inner tube. Performance at the lower end of the inner tube permits the flow of water. You can see on the figure, this is the journal arrangement of double tube core barrel. You can see all the parts of the double tube core barrels. Next is triple tube core barrel, good for obtaining core sample in fracture rock and highly weathered rock. Outer core barrel for inertial cut and second barrel to cut finer size, third barrel to retain core sample. Reduces frictional heat that may be damaged sample. It consists of stainless steel inner tube splits lengthwise inside a inner tube. The middle tube is mounted on an assembly that decoupled it from the rotating outer tube and isolates the cores from the drilling water. A latching mechanism retains the middle tubes in the place during drilling operation. Consists of a stainless steel inner tube splits lengthwise inside a middle tube. When the inner split tube is full, an overshot is run through the drill string on a wire ropes to retrieve core. Once retrieved, the split's inner tube is hydraulically separated from the middle tubes. By tugging, the core is inner tube snaps off just below a core catchers. Middle and inner tubes are released by a latch from the outer tubes, then pulled to the surface through the drill strings. The drilling strings remains in the boreholes unless the bit needs replacement. You can see on the figure outer core barrel and inner core barrel. Next is wireline core barrel. Wireline core drilling is a special type of core drilling most commonly used for exploration drilling. While drilling in medium hard and soft formation as are usually encountered in coal seams, sandstone, shale and coal, it is seen that in deeper holes more time is spent in hoisting and lowering of drill string for taking out cores sample after every 3 meters run in comparison to the time spent in cutting the 3 meter depth. With the objective of cutting the downtime spent in the hoisting and lowering of the drill string, the wireline system of drilling was developed. In drilling, the conventional equipment, the entire drill string with core barrel is required to hoisted out of the boreholes after every 3 meter run to take the core samples out and against lower back with the drill string to start the next run. With wireline drilling, a barrel of core can be removed from bottom of the holes without removing the drill rods strings assembly. When driller wants to remove the cores, an overshot is lower on the end of a wireline. The overshot attached to the back of the core barrel inner tube and the wireline is pulled back and the inner tube is disengaged itself from the barrel. For the wireline drilling, the rods are made of fine high tensile steel. This make then thin so that core can be large as possible. This process most of the time is available for drilling, and so speeder progress can be made with the same time spent in actual drilling. Hosting of the drill string is required to be done only when the bit has to be changed. Wireline drilling equipment is especially situated for drilling in coal formation, where the drilling depth involved are over about 200 meters. Normally, core barrels of 0.5 to 3 meter length are employed. Core size less than Bx is not possible with wireline coring equipment, which is there for used for drilling holes Nx and Bx size only. The speed of drilling with this equipment is nearly 80 meter per shift in the type of rock made within the coal fields. All the drill rods need to be withdrawn to the surface only when the bit has to be changed. Wireline drilling is possible up to the depth of 1000 meter. Stated earlier, the rod used for wireline drilling have specification as laid down in Q series decided by DCDMA. Ordinary drilling equipment can be adapted to wireline drilling and hosting with suitable modification. Wireline cable, a wire rope 4.8 to 6.4 mm is diameter is used to handle the inner tube of a wireline core barrel. At the end of the core runs, the drill string is broken at the top joint so that an overshot latching device can be lowered on the cables through the drill strings. When the reaching the core barrel, the overshot latches into the retractable inner tube assembly, which is locked in the core barrel during the core run. The upward pull of the overshot release the inner tube and permit it to be hoisted to the surface through the drill rod. It is then employed, serviced and lowered back into the hole. No details should be ignored, as this log may be the only records obtained for the particular site and will be relied upon in future year. Detailed description of core logging are presented by the Geological Society in 1970 and ISRM 1978. Important points to be noted down during the core logging period, those are given below. First, dates of drilling, next drilling method, drilling machine, make and model, drilling fluid types and amount, depth and type of casing, zone and severe core loss, problems that necessary casing, fluid losses, bad drilling zones, zones of several bit wear, groundwater levels and dates measured. Storage of core. The fundamental objective of core drilling is to be collect subsurface sample in the shape of core and sludge material in order to study their mineral assemblage, chemical composition, rock structure and physical strength for various purposes. After removing the core from core barrel, it should be placed in the core box in the exact order in which it is taken from the ground. The core box is a shallow tray 1 meter long with partition running lengthwise between which the core fits in to each compartment is 1 to 1 by 16 to 1 by 8 wider than the core diameters. The core box may be wood with hinged or screwed cover or with mild steel with rounded groove or rectangular cores compartment. As the core from each run is placed in the box, wooden blocks upon which the depth of the hole is written should be placed after the last piece of the core of each runs. Each runs in thus separated and thus shows the exact depth at which it was made. The arrangement of core box is done in different ways. Book fashion is like reading a book starting from left and proceeding to right. Snake fashion, it start from left to right in the first groove. Once the first groove is completed, the core are placed from right to left in the second groove, and so on and so forth. Book fashion is preferred the most as is speed up core logging, identification of footage at any point in the hole and less chance of error. Next is core recovery. Core should be stored in either wooden box or corrugated card box marked with boring, number, depth of core, run, type cores, bits, core recovery, rock type, RQD and other notes. Core operation should be well documented, loss of fluid, sudden drop of rock, poor recovery, loss of core, etc. Core runs taken in either 5 to 10 foot section and 5.5 to 3 meter section. Log the amount of material recovered. Rock recovery is percentage retained, which is expressed in percentage. Core recovery depends on quality of rock, mass, choice of the core barrel, skill of the operator, stability of the drill rig and lack of vibration. The formula of core recovery is the total core recovery is equal to sum of the length of core recovered upon total length of drill run. Rock quality designation RQD. The RQD is a modified core recovery measure of the degree of fracture, joints and discontinuity of rock mass. RQG is equal to sum of pieces more than is equal to 100 mm or 4 inches divided by total core runs, generally performed in annex size core. Mathematically, RQD is expressed as RQD is equal to summation of length of sound core rocks pieces more than and is equal to 10 centimeter upon total length of core run into 100%. You can see on the figure the schematic figure of RQD, in which core recovery and rock quality designation RQD are shows. Thank you.